mostly. Now it's okay na? Okay. Okay. So we are talking about the current. So basically what the current is, the number of charge particles, basically the charge which is being flown in this case. Just give me a sec. Yes. Here. So Q charge is if it is being flown through a cross section. Suppose this is the cross section of a wire और यहाँ से charge is being flown. ठीक है, throughout this cross section per unit time. So we measure this net charge divided by time, and this particular quantity, this ratio is termed as the current, basically I. ठीक है. Now, so in the previous session, we have talked about mostly instantaneous current and the average current. So instantaneous current के बारे में I have told you that it is the limiting case of average current when delta t times the current that is being flown for very short time. ठीक है. Very short time का means at that particular instant. Suppose you want to measure the value of current at t is equals to 2 seconds. So this is the current at t is equals to 2, not more than 2, not less than 2. So that particular value of current is instantaneous current, limit delta t tends to 0, delta q by delta t. And since delta t tends to 0, so this ratio is also very small. For a very small time interval, the very small charge particle will be flown. Okay, it's pretty much understood. So this will become dq by dt. Okay, I have solved a question for you, and you guys have also responded to that question. Now, how to calculate the average value of current, that we will be dealing in the alternating current chapter, but I'll just give you a brief here. Like average current, na, I average के लिए we suppose the charge flow is given you in terms of time. ठीक है, charge flow is not steady. So what you will do? Integration of q 0 to t dt divided by for how much time that charge is being flown. To that value, you can also calculate this average current. Okay. So there are two methods that I have told you to calculate average current. First is to you calculate what is the total charge being flown divided by total time is taken. Second, if charge is given in terms of this, in terms of function of time, or a variable charge is given to you. So what you will do, just integrate this charge and divide it by the time period. So that also gives you the average value of current. Okay. Now, to based on that, we solve a question first of all. The charge flowing in a conductor changes with time qt is equals to alpha t minus bt square plus gamma tq, where alpha, beta, and gamma are the constants. The minimum value of the current is, and I would like to say here that this is the method for the average current. Okay. Now, try to solve this question. Try to solve this question. Qt is given to you as alpha t minus beta t square plus gamma t cube, where alpha, beta, and gamma are the constant. The minimum value of current is what you have to find. Okay. So try to find out that value. What is that value? Okay. So how we are going to solve this question? Right. So first of all, Qt as a equation we have did in the last session also. So Qt here is alpha t plus alpha t minus beta t square plus gamma t cube. Okay. So we have to find out the minimum value of current. Minimum value of current. So this is the special condition here. Okay. So first of all, you have to find out the current itself, dq by dt. So dq by dt will become alpha minus 2 beta t plus gamma 3 gamma t square. Now those who haven't understand that key how we have did it, so we have just differentiate this expression. So differentiation of alpha t will become alpha minus beta t square. So only t square is a variable because alpha, beta, gamma and are the constant. So t square का differentiation will be 2t. So that's why I'm writing is at 2 beta t. ठीक है. t cube का differentiation will become 3t square. 3t square. Along with gamma, it will become 3 gamma t square. ठीक है. Now this is the value of what? This is the value of current. ठीक है. This is the value of current. And what is that current? Who is going to tell me? This current is average current or instantaneous current? Tell me. This current is average current or instantaneous current? Everyone. Very good, Nagashri. Very good. Very good, JNV Kokrajal. ठीक है. So this is the value of instantaneous current. Now this current has to be minimum. ठीक है. This current has to be minimum. So look here, the current represent the rate of change of this charge. So this current would be minimum. I would be minimum when this rate of change of charge would be minimum, and minimum value should be 0. So put dq by dt is equals to 0. This is the condition for this question. Now when you apply this condition, it will become alpha minus 2 beta t plus 3 gamma t square is equals to 0. So this is a what? This is a quadratic equation. You can see here. This is a type of quadratic equation. 3 gamma t square minus 2 beta t plus alpha is equals to 0. Okay. So for solving this equation, when you will solve this equation, what you will get? When you will solve this equation, you will get two values of time. Let's say t is equals to t1 and t is equals to t2. So in t1 and t2, you have to consider the positive value. Okay. And that particular value you have to put in this expression, in equation. So at that particular time, the current is minimum. ठीक है. हमने क्या किया? We have calculated dq by dt. To calculate the minimum value of current, we put this dq by dt as 0. ठीक है. So sorry. Just a second. dq by dt gives you the minimum value of charge. ठीक है ना? It's a little mistake here. That is why I'm saying कि quadratic equation is why quadratic equation is formed. ठीक है. Look, we need the minimum value of current. ठीक है. और जिस चीज का भी मिनिमम वैल्यू चाहिए होता है उसी का रेट ऑफ चेंज हम क्या कर देते हैं? 0 कर देते हैं विद रेस्पेक्ट टू टाइम. ठीक है. सो इन दिस केस when we want I would be minimum, so in that case di by dt should be 0. ठीक है. So when you put di by dt should be 0, so वहां पे क्या होगा? Again you have to differentiate this expression dq by dt. ठीक है. तो dq by dt को जैसे ही डिफरेंशिएट करोगे तो अल्फा का डिफरेंशिएशन इज 0 माइनस 2 बीटा t का डिफरेंशिएशन इज 2 बीटा प्लस 3 गामा t स्क्वायर का डिफरेंशिएशन विल बिकम 6 गामा into t, and this is equals to 0. So here you can see that time is equals to beta upon 3 gamma, because when you put this value as 2 beta, you can take 2 beta this side. So 2 beta is equals to 6 gamma into t. So 2 3 is 6. So t is equals to beta upon 3 gamma. Okay. This value you have to put in this expression. Now put it into this expression. Calculate what your calculation says. Everyone is understanding this question, na? At any point of time, if you are having any doubt, you can ask. So I minimum is what? Alpha minus 2 beta into What is the value of time? Beta upon 3 gamma. Beta upon 3 gamma plus 3 gamma into t square. So beta square divided by 9 gamma square. 3 gamma square will cancel out this 9 gamma square 3 gamma times. So ultimately what you have as alpha minus, this is 2 beta square by 3 gamma and this is beta square by 3 gamma. 2 beta square by 3 gamma minus beta, plus beta square by 3 gamma. So this is twice of this value. This is 2 beta square by 3 gamma. This is beta square by 3 gamma. So remaining will be alpha minus beta square by 3 gamma. ठीक है? So this is the answer. So option C is the correct one. Okay. So how many have you any kind of doubt in this question? Say yes and no in the chat box. Then we will move further for the topics. Any kind of doubt, guys? JNV Kokrajhar, Nagashri. Any kind of doubt? Sneha, Divyansh. JNV North and Middle Andaman. Okay. If you have any kind of doubt, you can ask. Okay. It's a very simple question and it's from JEE 2024. Okay. JEE means actually. Okay. So whatever we are teaching here to you, it's directly related to your competitive exam. Okay. Okay. JNV Gadag is saying explain once again. देखो, first of all, the expression of charge is given to us. Let me use a highlighter here. So first of all, expression is given to us in the form of charge. And what is asking? Minimum value of current. So current के लिए what we have, I is equals to dq by dt. So first of all, we have to differentiate this expression. When we differentiate dq by dt, we get this expression. This is the value of current. And which current? Instantaneous current. Which means by putting the value of time, we can get any value of current. ठीक है ना? So at any point of time, you can get the value of current at that particular instant. We need to find out that current is minimum. So current minimum के लिए, for I to be minimum, the condition is di by dt should be 0. This is the condition. Suppose in this question it is been asking ki when the current when the charge flow will be minimum. So for that dq by dt should be 0. ठीक है? So di by dt should be 0. अब di by dt क्या है? This expression का di by dt. I को फिर से differentiate करेंगे means this expression once again will be differentiated. So when you differentiate this expression, it is 0 minus 2 beta plus 6 gamma t. यहाँ से we got the value of time, beta by 3 gamma. ठीक है? So this is the time where the current is being minimum. So at that particular time पे, what is the value of current? We need to put this expression here. When we have put this expression, we get the value alpha minus beta square by 3 gamma. Clear everyone? Oh. Now move on to the next. So this is the topic that we are. So JNV Gadag, is it okay with you now? Have you understood this? Okay. 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 So this is the topic that we are covering in the previous lecture. So what you have to do, it's the Ohm's law. You have studied in the 10th class also. So I'm explaining, not going to explain it more and more in a very deep way. You have an idea that for any conductor, suppose any conductor you have, and when you apply a potential across it, potential is generated by the battery of voltage V. There is a value of current being flown through this conductor. So that particular current or this voltage has a relation. So this voltage is directly proportional to the current until and unless the physical condition and temperature remain constant. Now, when you are preparing for JEE, you should remember what are the conditions where we can apply this particular law. So to apply Ohm's law, physical condition and temperature remains constant. So suppose we are taking the example of your household. in your house or in your school there is a LED bulb or whatever the bulb is present there. Is that bulb following the Ohm's law? It's a very simple question to you. There is a voltage across the bulb. There is a current flowing through the bulb. Is the bulb following the Ohm's law? Now let's see who is going to answer. 37 student is here. Let's see who is going to answer. Sneha is saying no. Sneha has said clearly no. Okay. Now what else? What other has to say? So only Sneha's house having, I think, the light bulb. That is why she is observing this phenomena. No one has a light bulb. GNV Gadag, Divyansh, Kokrajhar, Nagashri. Okay, Bhagat is also saying ki no. ठीक है. Sneha is absolutely correct with the explanation also. Why we cannot apply this Ohm's law to the bulb? Because in the bulb filament, there is a filament made of tungsten. This filament has a temperature rise as the voltage flows or the current flows through the bulb. So temperature is not constant, and the first condition is temperature remain constant to apply Ohm's law. So that is why in bulb the Ohm's law is not valid. So this can be a question of assertion region type. Okay. So try to be aware of that these kinds of situation. Okay. So you can extract more and more. So here we can say that V is directly proportional to I. So there is something that is resisting the current. That is why we are increasing the voltage, then the current will increase. Not automatically it will increase. So which means there is something is there which is resisting this current. Okay, which is limiting the value of the current. So that is why we remove this proportionality sign and we say that it is replaced by R, which is the resistance. Okay, so we can say V is equals to I R, where R is nothing but R is the resistance of that particular conductor. Now, why the resistance is happening, we will see in the next slide. Okay. Suppose there are different formula you can make with this expression V is equals to IR. Suppose voltage and resistance is given to you, you have to find out current, then you can apply this expression. So to apply directly without even thinking about it, you must remember this magical triangle. So what you have to do, suppose you want to calculate the value of potential. So uh, you just hide this potential. Do it in your notebook. Draw a triangle here like this. We place here I and R. And this is divide, and this is multiply. So suppose we want to calculate the value of potential. So this wala tab go you hide. So only I and R is remaining and I into R. So V is nothing but I into R. Okay. Suppose you want to calculate the value of current. So current wala tab you will hide. So only V and R is remaining. V divided by R, which means V by R. Suppose you want to calculate resistance. So resistance wala tab you have to hide. So V by I, simple. So by using this triangle, na, you can have these equation directly. Okay. So it's V I R. Clear? Clear है everyone? भूलोगे तो नहीं इस ट्राइंगल को? सबको याद रहेगा ना? स्नेहा, भगत, वेरी गुड स्नेहा. ठीक है. Is it really helpful यार? This triangle is really helpful. ठीक है. क्लियर है सभी को? Everyone? All of you are not responding. That is very sad. ठीक है. Okay. So Ohm's law we can only apply when the physical condition temperature remain constant. Now what about the physical condition? Condition is pressure also. We include the pressure also here. And by physical condition, what do you mean? The length of the conductor, area of the conductor. These two situation also remain same. ठीक है. Now if you are changing the length of the conductor, then also the flow of current will disturb. If you're changing the area of the conductor, then also the flow of conductor will disturb. ठीक है. अरे please mute yourself. Who has put it? Who has put yourself on unmute? Please unmute yourself. Who has unmute? Please mute yourself. Sorry. Pawan Kalyan, are you the one who is speaking right now? Okay. ठीक है. तो physical condition से what do we mean? The length, the area, the shape of the conductor, and temperature and pressure also. ठीक है. Now, when we have studied that this resistance is coming out whenever we have a conductor, let's say of length L. ठीक है. So first of all, we will understand the phenomena why the current at a microscopic level. So suppose we have a conductor here. Let me draw it for you. We have a conductor. Let's say this. Okay. So this is the conductor that we are having right now. And in this conductor, there are lots of ions is present. You consider that there are lots of ions here. Positive charge is also here. Positive charge is also here. And negative charge is also here. But negative charge is too small. So I'm making this negative charge with the dots. Okay? Clear? So suppose what is happening when there is no electric field. No electric field. So when there is no electric field, what is in that case? When you see at the microscopic level, you just consider at a microscopic level, you will consider a cross section over here and you will see how much charge is flowing through that particular cross section. So let's say this is the cross section. Okay. So what we have observed that these electrons are moving here and there. Okay. So first concept that you need to know that when electron collides with each other, collides with elastic collision. So in that elastic collision, there is no loss of momentum, no loss of kinetic energy. Okay. So there is an elastic collision that is being happening with the charges, with the positive charge, negative charges. Okay. So electron collides with elastic collision. First of all, this information. Now, when there is no electric field, this electron flow randomly. So suppose we have considered a particular cross section. Okay. So in this particular cross section, when suppose 10 electrons are crossing, so 5 electrons are crossing into this manner and 5 electrons are crossing into this manner. So the direction of velocity is random. Direction of velocity of electron is random. Then you can ask why the electron is moving and there is no electric field present there. So it is moving because of the thermal motion, thermal kinetic energy, thermal kinetic energy. So always remember in 11th class you must have remember that key the kinetic energy is given by 3 by 2 kb into T, where T is the absolute temperature. So suppose this particular conductor is you have put at the room temperature, so it must have some thermal kinetic energy. Okay? So this motion of electron, which is very random, is because of the thermal energy. Okay? And also this positive charge also vibrate about its own axis. Okay? Clear? So here when अब हमें तो करंट के लिए क्या चाहिए था, एक पर्टिकुलर क्रॉस सेक्शन से हाउ मच नेट चार्ज इज बीइंग फ्लो, बट द डायरेक्शन इज सो रैंडम, सो नेट चार्ज विल बिकम zero. Okay, because of the randomness in the motion, because of the randomness in the motion of electron, the net charge is equals to zero. अब देखो positive charge is very bulky, positive charge is very heavy because positive charge contains all the mass of an atom. So positive charge is very heavy, it cannot move. So the movement that can only have with the electrons. So particular some materials is showing, because some materials are perfect lattice, crystal lattice. So the ejection of electron is very easy from that. Okay. So electron can move freely throughout the surface of that particular material. And that particular material is termed as conductor. Okay. Now, those material that cannot have the free electrons or the easy conduction of electricity, these are called the insulators. Okay. Now, if I apply the electric field here, let's say there is some value of electric field, let's say E naught. Okay. In the second case. So in the second case, when we apply the electric field, let's me show you here. ठीक है, अभी मैंने क्या कर दिया, इलेक्ट्रिक फील्ड इज अप्लाइड. ठीक है, इलेक्ट्रिक फील्ड इज अप्लाइड एंड लेट्स से इलेक्ट्रिक फील्ड की डायरेक्शन इज दिस. नाउ द इलेक्ट्रॉन विल मूव इन द opposite direction to the electric field due to a force of F is equals to E into capital E. So all the electrons will move into this direction. So the if you consider particular cross section now, so its cross section say there is a net charge which is crossing this cross sectional area. So here the Q net will not be zero. Why? Because there is a forceful push of the electron into the opposite direction of electric field, and that push is created because of electric field. ठीक है ना, और ये इलेक्ट्रिक फील्ड आई कहां से होगी, द बैटरी दैट वी हैव अप्लाइड. क्लियर है सभी को? अब समझ में आया करंट को माइक्रोस्कोपिक लेवल पे कैसे देखना. क्लियर है सभी को, एवरीवन? अब देखो यहां से आप रेसिस्टेंस भी समझ सकते हो, कितना ब्यूटीफुल कॉन्सेप्ट है. अब देखो जैसे इलेक्ट्रॉन मूव कर रहा होगा, सपोज दिस इलेक्ट्रॉन इज मूविंग फ्रॉम हियर टू हियर, तो क्या ये इजीली मूव कर पाएगा? क्या ये इजी पीजी मूवमेंट होगा इस इलेक्ट्रॉन का, इस पर्टिकुलर इलेक्ट्रॉन का? नहीं होगा. व्हाई इट इज नॉट द इजी मूवमेंट? बिकॉज देयर आर पॉजिटिव चार्ज ऑल्सो ना, पॉजिटिव चार्ज ऑल्सो. इट इज लाइक दैट सिचुएशन कि देयर इज अ बॉक्स, ठीक है, एंड देयर इज अ बॉल हियर, देयर इज अनदर बॉल्स ऑल्सो, and this ball you have attached with a string. ठीक है, and you are moving this ball, so you are forcefully moving this ball from one direction to another direction, but will the motion be straight line or a very smooth? No, it will make collision with the other balls. ठीक है, it will make collision with the other balls, but due to the forceful nature, because we are pulling it continuously, so it is forced to move it in the other direction. So that is why in this case also electron is forced to move in the other direction, although the movement is not very smooth, because it will make collision with the other ions present in the conductor, and that other ion is nothing but positive charge. Okay, and it do get repelled by the other electrons also. Clear hai? So that is why this is something which is opposing the current. ठीक है। अब देखो फ्लो ऑफ इलेक्ट्रॉन जितना स्मूथ होगा उतना ज्यादा बेहतर हमें करंट मिलेगा कि नहीं? क्लियर? जितना ज्यादा फ्लो ऑफ इलेक्ट्रॉन उतना ज्यादा करंट, द मोर इज द फ्लो ऑफ इलेक्ट्रॉन मोर इज द वैल्यू ऑफ करंट, but more flow of electron is opposed by some quantity something, and that something is collision inside it लेवल पे अगर देखें, when we see it at the microscopic level, ठीक है। So this is something that is opposing the current, and that opposing is nothing but the resistance. Clear है? So you can say that the resistance is the intrinsic property, intrinsic property, which means it depends on the material. Suppose there is a very conducting material, तो वहां पे क्या होगा, मोर फ्लो ऑफ इलेक्ट्रॉन विल बी पॉसिबल, सो मोर करंट विल बी देयर, ठीक है। बट देर इज अ पुअर कंडक्टर, सो उसमें लेस नंबर ऑफ इलेक्ट्रॉन विल फ्लो, लेस अमाउंट ऑफ करंट विल, ठीक है। सो दैट इज वाई डिपेंड्स ऑन मटेरियल टू मटेरियल दैट हाउ इट विल रेसिस्ट। दैट इज वाई व्हेन यू गो टू द शॉप, when you go to the electrical appliances shop, they will ask you what type of wire you want. You want a wire of copper or aluminum or something else. Clear है? Because it depends on material to material how it will behave. So resistance is the intrinsic property. Clear है? This is a very important point. अब समझ में आया सभी को? Everyone? Yes and no? करंट का माइक्रोस्कोपिक लेवल, yes and no? आज के बाद मत पूछना कि why the resistance is there. Resistance is not a God forming property, ठीक है? Resistance is the intrinsic property of a conductor, ठीक है? It is generated by the conductor itself. Okay. Everyone has to respond in terms of yes and no, यार. Now let's just coming back to the resistance itself. अब देखो resistance is a property of what? Conductor. So it will depends on, automatically it will depends on the stage and shape and size of the conductor. Can, because it is the property of conductor itself. So suppose when you want to see due to length, so due to length पे क्या फर्क पड़ेगा if we increase or decrease the length, ठीक है। So let's say there is a current is being flowing, or let's say there is a water pipe and some water is flowing through this pipe, okay? Suppose we have attached another pipe of same dimension, same length, so will the water flow will be disturbed? Everyone, will the water flow will be disturbed? Will the water flow disturb or not? अभी मुझे सबका नाम नहीं लेकर के बोलना पड़ेगा, है ना, कि भैया आप रिस्पॉन्स करो, ओके यू हैव टू रिस्पॉन्स, दिस नेम यू हैव टू रिस्पॉन्ड, डोंट डू दैट, ठीक है। सो अब मैंने यहाँ पे अगर कोई वाटर, मैंने सपोज 10 लीटर वाटर पोर किया इसमें, सो 10 लीटर वाटर इस तरह से फ्लो कर जाएगा, देर इज नो प्रॉब्लम विद द फ्लो ऑफ वाटर, ठीक है। बट इट हैज टू ट्रेवल अ लोट, सो दैट पंपिंग मशीन, जो मशीन इस वाटर को पंप कर रही है, नाउ इट हैज टू डू डबल वर्क बिकॉज द पाइप इज डबल। इन द सेम वे when we flow a current through a length L of conductor, ठीक है, and suppose we have applied a potential V, now to flow that particular current to a length, we again have to apply a potential V. So in this case, when we see, in this case resistance is directly proportional to length. Why it is directly proportional? Because Ohm's law apply करो, V is equals to I into R, ठीक है। So for the same flow of current, for the same flow of current in this 12 length of wire, you have to apply a twice of the potential I, and to make this current remaining as I, you must have twice of, ठीक है। So you can cancel this two. Again, you have having the same expression V is equals to IR, which means when you have to apply double potential, which means there is double resistance also. Okay. So on increasing the length, the resistance is increasing linearly. So that is why resistance is directly proportional to length. Second thing we can say, due to area, due to area of the conductor. So suppose let's say we have a cuboid here. One is this and another one is this also. Okay, placed on the up. So firstly, the current is being flowing through this only. Okay, through this only. Okay, this is a particular area A, जिसमें current flow कर रहा है. Now we have attached double area, but we don't want to disturb the value of current. So ultimately, what we have to do? Half of the current will travel to this, half of the current will travel to this. ठीक है? Suppose we have a bucket of water and we want to fill these two blocks. So firstly, the bucket of water goes to this when this is not present. ठीक है? So उस केस में क्या होगा? सारा का सारा पानी इसी में आ जाएगा. ठीक. But when we attach this particular box also, so वहां पे मेरा वाटर क्या है? इक्वली डिस्ट्रीब्यूट हो जाएगा. हाफ ऑफ द वाटर गोज टू दिस, हाफ ऑफ द वाटर गोज टू दिस, इफ बोथ द हैव सेम यूनिट. ठीक है. विच मीन्स बाई अप्लाइंग द सेम एफर्ट, एफर्ट मुझे सेम ही लग रहा है, बी मेरा जो मशीन है वो सेम ही है, क्योंकि अमाउंट ऑफ वाटर इज सेम बट इट इज हाफली डिस्ट्रीब्यूट. ठीक है. सो ऑन एरिया इफ यू विल सी, रेसिस्टेंस इज इनवर्सली प्रोपोर्शनल टू एरिया. ठीक है. रेसिस्टेंस क्या है? इनवर्सली प्रोपोर्शनल टू द एरिया. ठीक है. तो रेसिस्टेंस लेंथ की क्या होगा? डायरेक्टली प्रोपोर्शनल है. एरिया के क्या है? इनवर्सली प्रोपोर्शनल. ठीक है. क्यों? देखो, लेंथ के लिए हमने देख लिया था. लेंथ के लिए सपोज वी हैव दीज टू लेंथ्स y of length L, and this is also length L. Current I is being flown, so same current will be flowing this. There is no change in the current also. And potential, to flow this amount of current to this length, we have to apply V potential. So same potential we have to apply at this point. Suppose this wire is having a resistance R, this wire is also having a resistance R. Apply the Ohm's law. Ohm's law saying the total potential is 2V, current is I, total resistance is 2R. Okay. So from this equation we can say that by increasing the length, resistance is increasing. And in the same manner, if we double the length, resistance will be double. In case of area, let's say, in case of area, suppose this is the particular area. इसी में क्या था? अभी मेरा I करंट फ्लो हो रहा था. नाउ आई हैव डबल द एरिया. सो ये करंट तो सेम रहना चाहिए ड्यू टू कंजर्वेशन ऑफ चार्जेस. ठीक है. अब ये करंट हाफली यहां चला गया, हाफ यहां पे चला. लेंथ दोनों की क्या है? सेम है. और एरिया इसका क्या है? A/2. और इसका भी एरिया क्या, सॉरी, ए ले लेते हैं एरिया, और इसका भी एरिया क्या है? नाउ पोटेंशियल भी क्या है? सेम लगा होगा. पोटेंशियल भी दोनों के अक्रॉस सेम ही, क्योंकि करंट तो चेंज नहीं हो रहा ना. अब देखो, यहां पे हम कह सकते हैं अप्लाई द ओम्स लॉ, टोटल पोटेंशियल इज V, करंट इज व्हाट? I/2 प्लस I/2 विच इज I इंटू रेसिस्टेंस. के बारे में अगर हम बात करें, देखो सेम था यहाँ पे. R रेसिस्टेंस था इसका, इसका भी R रेसिस्टेंस था. अब यही स्लैब हमने कट कर दी थी हाफ हाफ में. जिसका एरिया ए था, इसे ही हमने हाफ हाफ में कट कर दिया. ये मेरे पास स्लैब थी और मैंने इसे हाफ हाफ में कट कर दिया, तो करंट भी हाफ हो गया और एरिया भी हाफ हो गया था. A/2. तो इसका मतलब है कि इस वायर का जो ऊपर वाला पोर्शन है, इसका रेसिस्टेंस भी हाफ हो गया होगा, R/2. ठीक है. और ये भी आर बाई टू हो गया होगा। क्लियर। सो यहां से हम कह सकते हैं वी इंटू आई आर बाई टू प्लस आर बाई टू। दैट्स वाई देखो ओम्स लॉ फिर से वैलिड है यहाँ पे, वी इज इक्वल टू आई आर। ठीक है, क्लियर है। अगर एक स्लैब पे लगाओ, सिर्फ पर्टिकुलर स्लैब पे, हम देखना चाहते हैं कि एरिया डिक्रीज करने पे क्या हो रहा है, तो अप्लाई वी इज इक्वल टू आई बाई टू इंटू आर। तो यहां से आप दे सकते हो वी आई आर बाई, resistance is getting half. ठीक है, so if the area is getting half, resistance is getting half, which means area is decreasing. ठीक है, तो एरिया के इनवर्सली प्रोपोर्शनल है रेसिस्टेंस। एंड दिस इज, इफ यू कंबाइन दिस, आर इज डायरेक्टली प्रोपोर्शनल टू एल बाई ए। ठीक है, आर इज डायरेक्टली प्रोपोर्शनल टू एल बाई ए एंड वी रिमूव दिस प्रोपोर्शनैलिटी साइन, सो इट इज रो एल अपॉन ए। ठीक है, this thing, this formula you have to remember, that R is equals to rho into L by A, where rho is what? Rho is what? Rho is the resistivity. Resistivity. ठीक है, रो क्या है यहाँ पे? रेसिस्टिविटी। ठीक है, नाउ मूव ऑन टू द नेक्स्ट। अब ये क्वेश्चन देखो, इस क्वेश्चन को ट्राई करो। चलो मैं ही करता हूं पहले, है ना। वी विल स्टार्ट दिस। अ वायर ऑफ रेसिस्टेंस 160 ohm is melted and drawn in a wire of one fourth of its length. मेरे पास एक वायर थी, सपोज दिस इज द वायर भी है। अब मैंने क्या कर दिया, इसे मेल्ट कर दिया। मेल्ट करके आई हैव ड्रॉन अ न्यू वायर ऑफ लेंथ व्हाट, एल बाई फोर। ठीक है, वन बाई फोर ऑफ इट्स लेंथ। द न्यू रेसिस्टेंस ऑफ द वायर विल बी, टेल मी। देखो आर इज डायरेक्टली प्रोपोर्शनल टू एल। ठीक है, आर इज डायरेक्टली प्रोपोर्शनल टू एन, सो वी कैन से दैट आर वन बाई आर टू इज इक्वल टू एल वन बाई एल टू। क्लियर है, इसमें तो किसी को कोई डाउट नहीं है। आर वन बाई आर टू इज एल वन बाई एल टू। अब देखो आर वन इनिशियली कितना गिवन है, 160 ओम। 160 डिवाइडेड बाई आर टू विच इज अननोन। एल वन इज वॉट, लेंथ इनिशियल लेट से एल है, और फाइनल लेंथ कितनी हो गई है, एल बाई। ठीक है, अब देखो दिस फोर विल गो अप, 160 डिवाइडेड बाई आर टू, एंड दिस विल बिकम 4, 4 एल बाई एल, एंड दिस एल एन एल will cancel out. This will cancel out this. So what it will become? R2 will become 40 ohm. ठीक है, क्लियर है। क्लियर है सभी को। ओके, नाउ आई वांट यू टू राइट few points. ठीक है, few points you should write about the resistance, which is very important. You should note these points. So point number one, point number one यहाँ पे है, if resistance of the wire, if, sorry, if length of the wire, if length of the wire, length of wire is increased by, n times, n times, So resistance will become 4 times, oh sorry, n स्क्वायर टाइम्स. अब देखो, अब आप में से एक भी स्टूडेंट ने, नन ऑफ यू नन ऑफ यू हैव पेइंग अटेंशन टू द प्रीवियस क्वेश्चन. किसी ने भी प्रीवियस क्वेश्चन में अटेंशन नहीं दिया. अरे, पहले वायर का जो रेसिस्टेंस था वो 160 ओम था. ठीक है. और अब हमने उसकी लेंथ इंक्रीज कर दी है. तो लेंथ इंक्रीज करने पे तो रेसिस्टेंस बढ़ना चाहिए था. देन व्हाई आर दिस रेसिस्टेंस इज डिक्रीजिंग? नो वन हैज फोकस. वेयर इज योर फोकस? टेल मी, वेयर इज योर फोकस? आर यू इन द क्लास? प्रियंका, स्नेहा, दिव्यांश, JNV कोकराझार, भगत, and all of you, not specifically these students, all of you. अरे, when we are increasing the length, so length increase करने पे we have seen here, when we increase the length, the resistance increases. Then why in this case resistance is decreasing? It is not possible, na? So that is why these options are given to you, so that in hurry you apply the concept and you get it wrong. ठीक है. That's why these options given to you. अब most of the student will confuse in this all, which means that, देखो, वायर ऑफ 1/4 ऑफ इट्स लेंथ, मतलब पहले जो लेंथ थी उस लेंथ से कम कर दिया है. ठीक है. पहले जो लेंथ थी उस लेंथ से कम कर दिया है. हाँ, स्नेहा इज गोट इट राइट. So that is why I am solving it in a wrong way. But no one had questions ki why have you shown increased length? Don't do that. Please be focused what you are teaching with. ठीक है. Length is decreased. So wire must be drawn like this. This is the wire now, L/4. That is why the resistance is decreasing. Very good, Sneha. Very good. ठीक है. What about others? Priyanka and all. Look, you have given the interview to being selected in this Enable Plus program. And now if you are not attentive the lecture, like not responding to the lecture, it's nothing for you then. ठीक है. ओके, सो डायरेक्टली यहां से भी सोल्व कर सकते हैं. देखो, लेंथ कितना टाइम्स इंक्रीज हुई थी? डिक्रीज हुई थी 1/4 टाइम्स. ठीक है. तो रेसिस्टेंस भी 1/4 टाइम्स ही, 1/4 का स्क्वायर टाइम डिक्रीज होगा. सो इनिशियली वैल्यू थी 160, फाइनली विल बिकम 160 बाई, या 1/4. ठीक है ना. 1/4 का स्क्वायर करेंगे देन यू विल हैव द वैल्यू. ठीक है. नाउ second thing is, and this is for when volume remain constant. Volume remain constant. ठीक है. Secondly, we can represent resistance as rho L by area. So we can say that this L is nothing but, if you uh, in terms of mass and area, you can also represent that this rho into area को you can write by d square L square m upon d in terms of density. ठीक है. Density is mass per unit volume. Mass and volume is nothing but length into area. ठीक है. So you can replace this area by this density, mass upon length into density. So this m upon uh, L we have put. ठीक है ना. So when you put it here, look, when you put it here at in terms of L, in term, विद रिस्पेक्ट टू ए की जगह पे क्या पुट करना है, एम अपॉन एल बाई डी। जस्ट अ सेकेंड। ए की जगह पे क्या पुट करना है, एम अपॉन एल बाई डी, सो इट विल बिकम एल अपॉन एम अपॉन एल बाई डी, वेयर डी इज द डेंसिटी। ठीक है, सो हियर यू कैन से दैट रो एल स्क्वायर डी बाई एम। यहाँ पे आप सिंपली देख सकते हो लेंथ इंक्रीज हुई है एल स्क्वायर टाइम्स। ठीक है, व्हेन द रेसिस्टेंस इज और वॉल्यूम इज कांस्टेंट। ठीक है, और this is for the length. Similar you can do for the area. You can calculate this value in terms of L, m upon a into d. ठीक है, so when you put it here with respect to length, L will become m upon ad. A is also present here, so it will become a square time. So if length is increased n times, it will resistance will increase n square time. If area is increased n times, then resistance will decrease n square time. ठीक है, क्लियर है एवरीवन? इट्स क्लियर टू ऑल? ओके, वेरी गुड। चलो, आई हैव लॉन्च्ड द पोल, जस्ट आंसर इन, जस्ट आंसर दिस पोल एंड देन वी एंड दिस लेक्चर। ओके, ओके, थैंक यू सो मच गाइस, बाय, टेक केयर।